Hi everyone, welcome to today's session. So this session is basically going to tackle the basic use of R, and this is a follow-up to the lecture on Model 1. So Model 1 is basically how to use R. So we will first start with some basic usage of R. So R could be used for multiple arithmetics. So this could be addition, multiplications, and so forth. So first and foremost, we're going to try this out. 5 plus 3. So after 5 plus 3, what you do next is to run this command. So you could just click on this button here, that's run. Now, if you use a Windows laptop, you could just go Control plus Enter, or if it's Mac, Command and Return. So whenever there is the run, that is what it means based on the PC. So this gives us 8. Now 12 minus 6. That gives us a 6. And then for multiplication, 6 times 6 times 7, that gives us a 42. All right. So the next is division. You could go 24 divided by 6. We have a 4. So the output shows at the bottom end out here. That's the console. This gives you the output. And this is where the script portion is. And you could go exponentiations like 2 raised to the power 4, and that gives you a 16. And we could do some modulo, that's the remainder after division. So that goes with 17 and then a 5. So the remainder here is a 2. And then we could also do integer divisions. So we could try 17. So 17, so let's say a 5. So that should give us a 3. Let's try this. Yes, that's a 3. Now the next section is to assign variables. So when we have certain objects, so I'll define what objects are. For example, we have A, so A could be an object, so you're going to make A an object. And to assign any variable, we could assign numbers to what A is. So for example, if I try A plus B, objects not found. Okay, but let's look at this. So we can assign by doing this. So less and a hyphen, maybe A is 10. You run this. Now let's assign 5 to that. Now let's rerun A plus B again. We have what? A 15. So it means that if assigned certain numeric variables to what A and B are. Okay. Now let's do some more manipulations. A minus B, that gives us a 5. Okay. And A over B, that gives us a 2. And then A multiplied by B, that gives us a 50. So that's what we mean by assigning. So we've created some objects. So one is A and one is B. Okay. Now, another way to view the results from what we've done so far, I just use the run. We could also use print to see what we have in. So let's say A plus B. It's all, there are different ways of viewing it, depending on the preference. So that's when we come to assigning. We could do other high order assessments, like maybe let's find the square root of 36. Okay, so that gives us a 6. Okay, we could even look at absolute value. So absolute value, you consider only the positive value. So let's say absolute of minus 10, and that gives us a 10. Right. We could round values. We could round to the second, third, or fourth decimal place. So we could go with 3.14159. And we place a comma and we place a 2. So you are looking at the second decimal point. So this should give us 3.14. So yeah, that's it. Now let's go with another modification. Let's go to 1, 2, 3, 4. So let's go to 4 places. That should give us 3.1416. Let's see. Yeah. So that's it. So you could round. So the first element here is your figure you want to round, and the 4 is how many places you actually want to do the rounding. The next thing you could even do, run natural log. So let's say log of 10, natural log of 10, that gives us 2.30. All right. You could go with exponential. So let's say exponent of, let's say 1. This one to give us 2.7. Yes. The next is to create some lists. So let's say we want to sum some numbers that we have in our set. So let's say 1, 2, 3, 4, and 5. So summing these should give us 15. Yeah. So now let's do it. We have it here. You could find a mean, but the mean, there's a catch here. We need to bring the C function here. That's the equation. So 1, 2, 3, 4, and the 5. Find the mean of this. That is we have 3. Okay. Now there are multiple times where you just want to possibly view what kind of data type that you have. So in R, there are multiple data types that are acceptable. So let's look at the first one. Probably let's create. So we have x is 10.5. If I assign 10.5 to x, so now we know what x is. It's 10.5. So we just look at the function class when you put in our x. Depending on what you have as your variable, you can set on that. So let's run this. That gives us numeric. Now, if we want to create an integer, I research that you need to normally put the L, the capital L letter at the end of it, suffix, to create an integer. So if we have 10 and we put an L here, then we go for class of Y, that gives us an integer. So that's it. And the next is characters. So characters are basically could be so characters are just non-numerical stuff or non-integer stuff, and also non-logical. I'll come to logical very soon. So we have a name. So we want to create a name called, let's say, Eric. So you see the double quotations here. Whenever you want to create characters, you need to always put in the double quotations. So now let's find what name is. What class does name belong to? So name here is a character. All right. Now we have logical variables. So we may consider something as true or false. Okay, so now let's create one logical variable. So out here, we want to say if anytime is a student, it should be false. Okay, so this here, we've run this. Now let's look at the class of is student. Okay, so that gives us logical. We could change this to true, and so true or false gives us logical. Also logical. All right. Okay. Now for complex numbers, R also accepts it. So for complex, we may have Z is 3 plus 2I. So this denotes what we call complex numbers. Let's run this. Now let's find the class of what Z is, and that is complex. Okay. Now we can also move to what we call data structures. Okay. So data structures, that is what most of us will be using in our analysis. We may have data structures or data frame. So data frame is a collection of data structures. So now let's create one numerical vector. So we may call this data one. So we want to create some numbers like 2, 3, 4, 6, and 4. Okay, 2, 3, 4, 5, and 6. That's our data structure. Okay. So this is what we've created. So we want to print what data one is. So we have 2, 3, 4, 5, 6. So this is a very simple form. You could also create how you call some character vectors. So let's character vectors. So for character vectors, let's say we want to create some number of fruits. So we do that, and we have apple, mango, let's say orange. Okay, so it's colored because R is sensitive to some color coding. So if you have red, orange, because orange is a color and a fruit at the same time, if it's coloring or if you want to assign a color to a graph, once you put in orange, it's going to give the shade of orange behind it just to give us that this is actually orange. So let's run the fruits. Now let's look at how fruits is. Okay, so we want to look at what we have in fruits. So that's what we have here. Now the next thing we could do as a build up is to access elements in a vector. So for example, the first, this is um, a numerical vector. Okay, so we could access the level, or we could access some number positions of some of the elements. So now let's try this. If you have data one and the square bracket, if you put in two, two means what is the second element in this set or in this set of numbers? So we have 2, 3, 4, 5, 6. So the second element here should be 3. Let's run and see if it's going to pop up 3. Yes, we have 3 here. If you modify this and make it, let's say number 4, the fourth element, that should be 5. Yes, so that's what we have. The same for fruits. If we have fruits and we're looking for the second element of fruits, that should be mango. So that's what we have here. Yeah. Okay. Now, for numerical vectors, we could manipulate them. So we have data underscore 1 is 2, 3, 4, 5, 6. So what we could do again is to do this multiplied by, let's say, 5. So it means whatever we have here, that's each of these members is going to be multiplied by 5. So that's what we have here in our console. That's the output. Let's say we want to add another set of numbers to it. So we can create a new set of numbers. So we could have, so there are 5. So we have 10, 20, 30, 40, and 50. So what happens is you would have 10 adding to 2, 3 plus 20, 4 plus 30, 5 plus 40, and then 6 plus 50. Let's see what happens here. So that's it. That's what we have here after running this. Okay. So that is what we have. The next is sometimes you can have matrices. So let's try and create, you can create your own matrix in R. And so let's try and create our own matrix. So we have matrix. So the first element could be what is your range. So we want to range from 1 to 9. And you specify your number of rows that you need. So we need 3. And then we also specify a number of columns. We need 3. So now let's run and see what kind of matrix that we created. You could just leave this as math, run it. You're still going to have or print, will give you the same outcome. So we have our matrix here, 3 by 3. Let's try another one. You could just modify. Now let's make it 1 to 12. So it means you need a 2 by 6, 3 by 4, 4 by 3. Let's select 4 rows and then 3 columns. Let's find out here. This we have. So this is a very simple way of creating your own metrics. And whatever metrics you have, you can select certain elements that you want for a metric. So now we have 1 to 12 and then 4 rows and then 3 columns. So now let's select, so math 1 and 3. So this means we want the first row and then the third column. So if you look at the output here, the first row, and that should be 9. Let's see what we have here. Yeah, that's 9 we have here. Now, if we want to select only a row, so let's specify the third row only, a comma, and then you leave it blank. It means you're selecting the third row with all the columns. So that's the third row. And we could select not, we select the, maybe the, how many columns we have? We have 3. The second column. So we leave a space, put in 2. That means second column. That's it. So that is another way you could just be selecting out your elements from a matrix. Okay. And the next thing to look at is, now let's try and create a list where we have more than one class. So let's create a list where we have a name, a character, um, could have a numerical value, logical, and then yeah, let's try and do something of that sort. So let's create a person, and this is the creation. So this list, from here we build up on it. So the name, we want to call the person Eric, and how old is Eric? So age is 45, and then is student. Now we're trying to input one, logical is false. And what are the scores of Eric? So you could, okay, 78, 86, and 93. So now let's create this person. So yeah, we have this, and you could just type in person, run, and we have our, so the name is Eric, age 45, the student, for scores 78, 86, and 93. All right, so we could do some manipulations with person. So now let's find out what name. So we bring in the $sign, so that pops up the various components or columns. So we have name. So what name do you have here is Eric. Now we could also look at person and then look for scores. So it is going to print out all the scores. Now we had a function where we could select or index a particular location or a particular level. So now let's select the second element in scores. If you look out here, we have 78, 86, and 93. So the second number here should be 86. Let's figure out if it's going to pop up. We have 86 here. So that's how you can manipulate. And then, so yeah, I'll just leave this, yeah, this what we call a list. Now, let's build up on a list. So the next is what we call data frames or data frame, where you have multiple lists. So you have lots of columns and then some names or some rows. Yeah. So let's create maybe a class. So we have some students in a class. So we have data.frame, and now let's get our, so name. So the name we could, let me think of some names quickly. So let's say we have John, we have Alice. No, we should come after. We have Alice, and then we have Bob. Okay, so yeah, yeah. So we have Bob. Yeah. So we put in a comma and then add the next column. So you can look at age. So the ages could be 24 to 35 and 43. So I'll talk briefly about the arrangement. And we have maybe GPA for this students. So we could add 3.8, 2.7, and then 3.3. All right. So we have name, age, GPA. Yeah, so that you add a few columns, but let's just stick to this. So in creating a data frame, each location corresponds to the next. What I mean is, if you have name like John, Alice, and Bob, the first element is John. So it means that the first element in age 24 corresponds to John's age. The first GPA 3.8 corresponds to John's GPA. Likewise, Alice is the second, so 35 corresponds to Alice's age, and 2.7 corresponds to Alice's GPA. And then finally, Bob, that's the third. His age is 43, his GPA is 3.3. So let's run this. Okay. What are we having here? Oh, so we need to take out, we need to look. So let's find out where. So yes, so R is very interesting. So after 2.7, the next should be a comma. So this is where the error is coming from. So that is one thing about R. Your commas, your capitalizations are very key. So that's what you need to look out for. Okay, so we have it. So now let's print what belongs to students. We can also view it. It's going to pop up show us a table form. So this is what we have. Okay. So one good thing is under students we have age, GPA, and name. So now let me show something here. If I type name, it's going to give me Eric because that's the first name we had from the person. So that's not a good example. Yeah, let me use GPA. GPA has not been used. So GPA is not found. Okay. So what you can do is if you have a few columns and you know the names off head, you could use the function called attach. So if I attach students, I don't need to use the dollar function in specifying or recalling. Okay, so I'm going to show you something. So attach students. Okay, now it has been attached. So now if I type GPA, it should work. You see this? Yes. But so that's another way. We are just trying to figure out some of the functions or some of the manipulations you could do in R. So now let's access the student names. So let's go students, $ and name. We have John, Alice, and Bob. Okay. We want the second person on the list of student names. So let's put 2 here. Who do we have? We have Alice. If you put 3 and so forth. All right. All right. Now for the students data frame, probably we want to look at the first row. So the first is the row, the second is the column. So all right, so they pick first one, not second. So first, the first one here means the row and then the column. So without nothing at the column section, it means I'm picking only the row. So the first gives us John. John is the first row. So that is one thing also to look at. So that's data frame. Yeah, so most of our data we're going to be analyzing will be in data frame format once we import. So that's something to take note of. The next is what we call factors. So factors could be anything with level. So like if you have sex or gender in your data set, so you have male and female, if or any classification that requires different levels, like probably performance with low, medium, and high, that could be a factor. So let's create a factor with gender, then or let's say with let's say performance of some workers. So we name it perform, and then we have factor here. We're creating a factor with performance. Yes, and then so we have low, medium, I need to put in because it's characters, it needs to be in double quotation, medium, and then yes, still this, and high. So that's the factors. So we've created our perform. So if you want the level of any factor, so let's look at now levels of perform. It should give us some levels. So we have high, low, and medium. Okay, so that's how to extract or figure out what levels you have in your data set. All right. Now the next is looking at creating and then importing data sets. Okay, so we are going to do it backwards by exporting and then importing. So since you already have a data of students, let's try to create a CSV file for the student. So we go by the right. So creating. Okay, let me use exporting. So exporting data set. Okay, so we have write.csv. So write.csv, and what is our main data? That's the objects that we created, students. How do we want it to be created? Maybe students one and a CSV file. Okay. Now we have this section as our, okay, let's keep this as our working directory. So that's what we have here. So we should have it in here very soon. Yeah. So sometimes it doesn't populate automatically. So what you could do is just move back by one level. You can do. So we have it here. Student.csv has been created. So that's what we have here. Now let's assume this was in already, and now we want to import it into R. Now we are different data sets. Some are CSV, Excel, could be R data, but this is just a CSV file. You look at the other data options. So we want to read this CSV file. Read CSV, and it's called students underscore one dot CSV. Okay, so that's it. So we've imported our data set and we can work on this data set. Okay, so that's it's a very simple way to look at this. The next is to probably look at subsetting data. Okay, so if you have a data you might want to recreate or reorganize or reorder or add on a new column. That's what we're going to do. So now let's look at our students data. So we want to, that's what we have here, our students data. That's what we have. Okay. Okay. So you realize that now we have X here, right? X one, two, three. We can change that. So let me show something here. We imported our data students underscore one dot CSV. So what we could do is to call this data two, so that it would be very easy for us to manipulate. So over here we could just introduce what we call row dot names. So we don't need that, so we could make it false. So now let's row the names of students. Okay, so let's look at something here. All right, so let me just view this. Okay, let me view this. So let me view what data2 is. Let me just view it. So data2. So this X here, okay, let's try to get rid of it. So students, let's go back. Let me do that with our exporting. So once we're exporting, let me not export that so that we don't find challenges when we are importing. So I'm saying you should omit that. All right, so now let's import. Let's view it now. We don't have it anymore. Okay, we've taken care of the X, we've taken care of it. So that's what you need to do. Okay, so now let's do the subsetting. So we have print students. So we have as data2 now. Yes, we can just, so data2. Now we want to look out for some young students. So students who of particular age, let's say less than 40. So young students, we want to subset that some young students. So we put in and then data2, then dollar sign. Age is our threshold marker. So less than 40. That's what we need. So now let's run it. Now let's print what young students. Now let's find out what it contains. So it contains everyone apart from Bob, because Bob is 43, so Bob goes above the threshold. So you can use GPA to define your threshold or whatever numerical value you want to use to move about your threshold. Now let's add on another. So we could also add columns if you want to. So let's stick to just these data underscore 2. So we could add a grade. Okay, we had GPA, so let's try and then add some grades to it. So data 2, we want to add grade, and grade will be A, B, and C. So that's character. So we need to, so the first one is 3.8. I think it should be an A. We are just assigning with no particular characterization in mind. Let's put here C, and then maybe 3.3 should maybe be a B. All right. So we don't have any grade here now. Now we want to add grade to data 2. So now let's print data 2 now. Let's look at data 2. Now it contains a grade A, C, and B. So you could add and add and add any column that you just want to add. So that's it. The next is to possibly create a logical column. So we have our GPAs as 2.7, 3.3, and then 3.8. So let's create a descriptive column for our grades. So now students, so grade, so we have the data 2, and then we want to, if a student should pass, then data 2 GPA should be greater or equal to 3.0. All right, so now we have this. So now let's look at our data 2 again. So now we have a pass column with true, false, and so everybody who is true means they passed. It means they had a GPA of 3 or more, which is true for John and Bob. That's how come you find true across their names. Okay. Yeah, so that's basically got a few things to do. You could also run some descriptive or summary stats. So for the descriptives, you could go broad. So if you put in the function summary and then you go with data 2, it gives you everything. So let's go through this. So name is, the length is 3, the class is character. Okay. So the length means there are 3 different names in here and it's a character class. And for age, it's giving us the minimum age, that is 24. And the last column, the last row here is the maximum. So that gives you the range, 24 to 43. You see the first quartile, 29.5, the median, 35, the mean, 34, the third quartile as 39. Likewise for the GPA. Now for the grade, it gives you, there are 3 different grades, A, B, and C, and that's a character. And for the pass, the mode is logical. So there's 1 false and then 2 are true. So that gives you a broad overview. So sometimes you might want just a summary for, let's say, age. Okay. So you could go summary data underscore 2 and then you select for maybe age. It gives just age alone. Okay. And you could also go very specific. Maybe you want the mean. Let's say we want the mean of GPA. Then you run it. That should be it. So that's your GPA for it. Yes. So this is basically a few things you can do in R. So this is the, you want the minimum value. Let's try and use the minimum. Beta 2, and then minimum value for the grade. That's A. Okay. This is, yeah, this will actually give us, because A is the first one, but yeah, we can't really use this for a character. So let's use age. Yes. So yes, 24 is a list. Yes. So that's a few things you can do with this. Okay. So the next, we initially spoke about packages because you want to go ahead and use R, you have to install packages. Okay, so you can come to this function here, packages, install, and then you make sure it's on the current repository, and then you enter the kind of package that you want. So if it's ggplot, then you install it. You click install. I already have it installed, so I won't do that. Or you could use the very simple one like install packages, and then you specify if you know the package you are looking out for. Just install. I already have it installed, but yeah, I just like reinstalled. And I researched that whenever you want to use a particular package and you've shut down the R and you need to work on the particular package, you have to recall it or call it or load it. So use the function library and then you specify the particular package you need and it's being called. So you do this for every package. So before you start your analysis, make sure you know the kind of packages that will be used in your analysis and then you load all of them. If they are not installed, you install them, then you load them prior to begin so that you don't have any errors. It's always easy to, before you start, you load your packages. I didn't do it initially because I was just going to work with basic usage of R and what to actually look for in R. Okay. And to repeat again, the side we having our inputting for our scripts, that's the script page. That's where you normally have your scripts. And the lower portion where the output comes out, that's the console. You see whatever you're doing, and that gives you the R output. In the upper channel here, so you have your environment, your history is everything you've done. If you've not cleared it, it will actually show you the history, the connections. You may not use connections unless for more advanced. So just the environment and the history, just showing you what you're doing in R. This broom here is just to clear your memory or clear everything, but you might not need it if you've not run out of memory. And the right lower section here where I have files, this shows your working directory. So you can always change your working directory. If I want to change it to R module, I just click on more and then I click on set as working directory. It means it's changed it. If I want to move back to folder 1, I just reset it. That's my working directory. And you have your plot here. If you have any plot, which we'll be looking at in our subsequent lectures, you have a plot here. You visualize your plot here. This is the one I used earlier. Packages where you kind of. And now for help. Help is a very good tool. If you have any package you're not very conversant with, you could just type in the package's name and it gives you everything. All the arguments that you need for the package, everything about the package, you are actually going to find them here. Okay, so that's one good thing about R. Another thing is you could also have your 2 question marks here and maybe ggplot2. So what it does is it will open up this for you. So it's giving us everything we should know about ggplot2, how to the arguments you use in your plotting, so you can look out for any of them if it's, and we'll come to that later on. But what I'm trying to show is you can, every package you can get a help or more details about any package that you think you need. So this comes to the end of the basic usage and how to just get around with R. So the next will be an upgrade of this where we're looking at chi-square in the model 2 section, and then correlation as well. Have a nice day. You meet again.